Well, hello and welcome to today's webinar, How to Pick Your Pixels, Format Selection, and Specifications for Digitization. For those of you who don't know me, I'm Biz Gallo, the statewide Digitization Initiatives Coordinator for the Library of Michigan. My job is to help libraries and cultural heritage organizations throughout Michigan digitize their collections and make them more accessible. Now, after laying the foundation for digitizing collections in last year's 9-part Digitization Basics webinar series, which you can view on YouTube, we're going to dive a little bit deeper this year with the How to Pick series, which will cover a variety of topics in a little bit more detail. So for example, we're going to be having format-specific classes such as digitizing newspapers, scrapbooks, and audiovisual material. We'll have resource-centered classes such as working with vendors, working with interns and volunteers, and building a community archives. We'll also have procedural classes such as writing digitization grant applications and creating digital exhibits. As always, if there are particular topics you're interested in learning more about, let me know so that I can continue to provide you with the resources you need to create and care for your digital collections. So before we get started, I'd like to go over just a little bit of housekeeping. This webinar is being recorded, so you can access the content again later along with a copy of the slides. The recording should be available in about a week or so, allowing time for captioning. So if you miss any of the classes in the series, you can always view the recordings by going to the Library of Michigan's webinar archive. There will be time for Q&A at the end, but feel free to ask questions throughout the webinar by dropping them into the chat, and we'll try to answer them either during the webinar or at least save time at the end. If you have any technical or audio issues, please reach out to Becky in the chat so that she can help you resolve them. And last, there will be a slide with links to all of the resources I'm going to discuss today, so you don't have to scramble to copy them all down or save them. You can also explore these resources and many other additional resources on the digitization page of the Library of Michigan's website. So today we are going to be looking at what goes into making a decision about file formats and specifications, options for selecting file formats, and options for selecting file specifications. So at the end, we're going to finish up with an exercise where you'll get to put what we talk about today into practice. But before we dive in, I'd like to start with just a few polls. So let's start with our first poll. And Becky, if you want to go ahead and launch that, that would be great. So this is, what are you currently or planning to digitize? So this is multiple choice. You can feel free to, select anything that you're going to be digitizing or plan to digitize. Okay, lots of text documents, lots of images, audio, video, 3D. Great. Okay, well, it seems like overwhelmingly people are going to be looking to digitize text documents, which is great because we're definitely going to touch on that today. And let's go to, and I'm going to go to the next poll, which is, what are you least sure of when you're selecting specifications? File format, resolution, color, bit depth, or other. And if you select other, please feel free to drop it into the chat so we know what it is. Looks like mostly across the board. Here, I will end the poll. So it looks like mostly bit depth is what people are most unsure about, but otherwise file format, resolution, and other. And it looks like in the chat, it says other is all the many specifications you can set for PDF files. Ooh, okay. Well, we'll touch on PDFs a little bit, but definitely good to write down to address in future webinars. Well, great. Well, hopefully after today's webinar, you'll feel much more confident about your selections for digitization. So let's get started by taking a look at what goes into making these decisions. So the first thing to know when you're planning a digitization project is that there's not going to be one right answer. You're going to need to make choices about your outputs based on a variety of factors, which will hopefully lead to a decision that will result in long-lasting files that meet a variety of needs. So there are several considerations when determining file format and specifications for a digitization project. First, the original format will have a huge impact on what file formats are appropriate or what will retain all of the necessary information from the original. For example, if you're digitizing an image, such as a photographic print or a negative, you would have a different file format than digitizing textual documents or audiovisual materials. Now, whether you're digitizing analog content or migrating or transcoding born digital content, that would also have an impact on what the appropriate file format would be. Now, I'm not going to discuss born digital content in this webinar, but it's definitely something to keep in mind if you're looking to migrate or transcode files. You must also consider the size of the original. As a general rule, and I'll be using a lot of general rules today, the smaller the original, the larger the resolution is needed to capture all of that content. Now, once you've made determinations about what the original format is and what would be the most appropriate specifications for those particular items, you'd also need to consider what your equipment is actually capable of capturing. Scanners and cameras can only capture up to a certain resolution, depending on their model and type. You may also have a scanner that can capture to higher resolutions, but it may take significantly more time than other models to do the same work. So you might have to make decisions to scan at a slightly lower resolution in order to be able to complete a project in a given period of time. You would also have limitations on file formats. I've seen a lot of people interested lately in overhead scanners that can scan sufficiently high resolutions, but their only outputs are highly compressed file formats such as JPEG, which wouldn't be appropriate for long-term preservation. And we'll talk about more about compression and file formats later on in this presentation. All right, so going on, we can say that, okay, pie in the sky, we've had the equipment to digitize all of your content to the best, highest quality standards. You still have to store and manage those files over time. Now, while the cost of digital storage space has been significantly reduced in recent years, if you're going to be doing digitization at scale, that cost can add up quickly. If you're digitizing audiovisual material, it will fill up even more quickly. This can be very expensive very quickly. This could have an impact on what bit depth or resolution you choose, as well as file formats, which can easily double or triple a file's size. Depending on the original format, you may want to choose a losslessly compressed file format over an uncompressed file format to save on storage space. Now, even if you can afford limitless digital storage, which I know I can't, I don't know if you can, and if you do, what institution do you work for? It's also important to consider that there are environmental impacts on digital storage, which rely heavily on natural resources for the metal and the hard drives that we use, and often aren't recyclable, or the amount of resources that it takes to cool data servers. Last but not least, you'll want to have a sense for what the use of the digital surrogate will be. And we never know all of the ways users will interact with the files we create, and we hope that we will find new and innovative ways to do so. But most of us have at least a basic understanding of how the files we create will be used. For example, if you're digitizing to deposit with a federal agency, such as the National Digital Newspaper Project, you will have to meet certain standards. But if you're planning on reproducing the digitized material in a publication or to be enlarged for signage for an exhibit that you're going to be hosting, you'll likely need to digitize to a much higher resolution than something that would be viewed on a standard computer monitor. So if you're digitizing textual material and plan to run optical character recognition on the files, you'll also need to digitize to a higher resolution or choose between bitonal or grayscale scans to make it accessible for the OCR software. Now, as you can see, there are many factors to consider when selecting the file format and specifications for digitization. But how do you even start on trying to make these decisions? Well, luckily for us, there are some very smart people out there who have done a lot of scientific research and testing to create standards for various aspects of digitization. Standards are important because they ensure consistency across your organization and interoperability across a wide range of users. This is especially important in a digital world where files are being created and shared across the globe. Sometimes there aren't official standards that we can point to. Rather, there are de facto standards or best practices that are in place as organizations try to create and finalize standards. Now, depending on the standard, they can be incredibly complex, nuanced, and difficult to understand, or even parse out the relevant information. In the world of digitization, we have a useful resource that we can point to that distills some of the standards into a set of guidelines that we can follow for our own work called FADGI. FADGI, which stands for the Federal Agency's Digital Guidelines Initiative, is a collaborative effort started in 2007 by federal agencies to articulate common sustainable practices and guidelines for digitization and born digital historical, archival, and cultural content. FADGI is made up of two working groups, one for still image and one for audiovisual material. Among other tools, FADGI publishes guidelines to distill ISO standards into common format that can be more easily understood by a variety of organizational types and experience levels. Just last month, FADGI released its third edition of Technical Guidelines for Digitization or for Digitizing Cultural Heritage Materials, which focuses on still image digitization. The guidelines provide contextualization for various aspects of digitization, evaluation for benchmarking equipment, format and equipment recommendations, and high-level processing workflows. Now, unless you're depositing content with a federal agency or working with a vendor, these guidelines will likely be more informative than prescriptive. I do highly recommend reviewing these guidelines if you're planning on digitizing still image material. It is also good to have because it has very useful charts that serve as a great quick reference guide. So the guidelines include evaluation criteria organized by specific media types, such as bound materials, unbound materials, maps, newspapers, photographic prints, photographic negatives and transparencies, paintings, X-rays, and microfilm. FADGI uses a 4-star evaluation system with 4 being the best, 3 being good, 2 being acceptable, and 1 only acceptable for some limited use cases. Now, the target that we're aiming for is for a 3 or 4-star level. A digital object star rating is determined by meeting FADGI evaluation parameters through image analysis. We're not going to go into benchmarking and analysis in this webinar today, but it is important to assess your equipment and ensure that your targets are being hit. The FADGI guidelines also include a helpful chart for file formats, resolution, bit depth, color space, and color mode recommendations for each of the material types. You can see even from this example that there is not one right answer. There are multiple options for file formats, resolution, bit depth, color space, and color mode. At the least, this helps you narrow down your choices into something a lot more manageable. And when you make your decision, be sure to document these decisions. This could be on a per project or per format basis, or even across your whole institution. It helps to create consistency across digitization projects, and we know that knowledge management is becoming more and more important with the increased level of staff turnover at many organizations. Not only will future staff thank you when they don't have to start from scratch, but likely your future self will thank you when you come back to a project in a month or a year down the line and try to remember what the decision you made was and why. A helpful tool for documenting these decisions is the Digitization Project Planning Guide, which walks you step by step through factors to consider when digitizing material. It has a section where you can specify the file format and specifications you'll be using for that project. And not only will your team have it and know what the target is that they're aiming for, but you'll also have something to perform quality control checks against down the workflow. Okay. So now that we know what goes into choices surrounding file formats, let's take a look at some of our options. First, let's take a second to identify what a file format is. When we think of file formats, TIFF, PDF, JPEG, and more come to mind. Now, in these instances, we're actually describing the file's wrapper, or the 3-digit suffix after a file name, .tif, .jpg, .pdf. Now, just like a candy bar wrapper, this wrapper encapsulates the candy bar, tells you what's inside and its ingredients. We know what's going to be inside when we unwrap the candy bar because of how it's packaged. A file format, which we often refer to colloquially as its wrapper, is the set of conventions that define the different elements of the file. The file format defines the bit stream, the embedded metadata, and its wrapper. Now, this is a little bit more relevant for audiovisual files that have contain many bit streams, but it bears mentioning here as we're talking about file formats. Now, when it comes time to select your file formats, you'll have a few decisions to make. It is recommended that you have at least 2, possibly 3 files for each original: a preservation master, a production master, and an access copy. Each file type will have its own use, and you'll determine what level of adjustment is needed for each. First is the preservation master, also called the archival master. Master file formats should be widely adopted formats, suitable for rendering large files and containing robust data. These are the highest quality files created during digitization. They are often uncompressed, have a wide color gamut, and the highest bit depth and resolution needed to represent the original. These are the files that should have actions taken to ensure the sustainability over time. Now, the goal is that you can digitize once to this file and then be able to create a variety of derivative files for particular uses from that file. The next file is the production master or service copy. This file is optional depending on what the original is, but there are 2 general reasons for creating production files. The first is to compile separate elements into a single file. For example, you could be stitching together digital images from a large map into a single file. Or you could be creating a single audio file from a multi-track audio recording. The second is to adjust files for aesthetic or technical purposes, such as cropping out a color guide from a photograph, reversing a negative image, or removing clicks and pops from a digitized recording of a disc. Now, this is not a license for slapdash approach to digitization, thinking that any issues you have could be fixed in post-production. Rather, FADGI guidelines recommend that image processing should be reserved for optimizing an image rather than for overcoming poor imaging. The production master file is either going to be at the same quality as the preservation master or at a high quality or high resolution. Derivative files are then created from these production masters for an overall better user experience while still leaving the preservation master file or files untouched. Last will be access or use copy. This will be made from either the preservation master or the edited production master file if one exists. Access copies are reduced in size and quality for easier access and sharing via the web. Access copies are often compressed. There are compressed file formats such as JPEG, MP3, or MP4, depending on the media type. Which brings us to compression. Compression is when files are reduced to be more easily stored or transmitted. It is not inherently bad, but it is important to know that there are types of compression, what they are, and when each is appropriate. There are a few different flavors of compression: uncompressed, losslessly compressed, and lossy compressed. Uncompressed is when none of the information is reduced or removed. Uncompressed file formats are usually for preservation master or production master files. Now, unfortunately, as we've noted, these files are also quite large, and so you have the option to select a losslessly compressed file format. Compressed formats can be categorized as either lossless or lossy. Lossless compression is when data is encoded in such a way that it packages redundant data and more effectively and more efficiently in a way that can be decoded to be exactly the same as the uncompressed data. That way, nothing is lost, not a single bit. For example, 100 million can be represented by 100000000. It can also be represented as 10 to the 8th power. Now, both representations equal the same thing, but one is represented using far less data. It takes some computing to decompress 10 to the 8th, but it does equal the same. Alternatively, lossy compression compresses files, but it does so by throwing away data instead of it does this by throwing away information. That information cannot be recovered when it's decompressed. Now, this isn't necessarily a bad thing, and depending on the environment or the use of the file. For example, a TIFF file or a WAV audio file would be far too large to adequately stream on a website. So a compressed JPEG or MP3 file is used in its place for a better user experience. This gives the user near instant access versus waiting for the large file to load, if it even does. Now, if we watch this example of a JPEG being saved over and over again, we notice the accumulated loss for those compressed elements over time. Now, this isn't an issue for an access file, but it would be catastrophic for a preservation file. Can you imagine opening up a preservation file and seeing all those missing blocks? Now, this is a good illustration of why compressed file formats are not a good choice for preservation master file. But what does make a good file format? To better understand and compare available file formats and their likelihood of remaining viable option for digitally preserving information into the future, the Library of Congress established and regularly updates its Sustainability of Digital Formats document. The resource provides detailed information about hundreds of file formats and evaluates them on 7 factors: disclosure, adoption, transparency, self-documentation, external dependencies, impact of patents, and technical protection mechanisms. The Library of Congress also annually updates its recommended formats statement, which lists both preferred and acceptable file formats that they believe will best meet the needs of the library in its goal to provide access to the content into the future. Now, we're not going to dive into these resources, but if you're curious to learn more about various file formats or compare them, these are great resources for you to explore. As we can see, the choice of preservation file format has a direct impact on whether and how a file will be available into the future. So starting with still image, the TIFF, or Tagged Image File Format version 6, is the preservation master file format of choice for cultural heritage organizations and has been so for decades. This is a safe choice for preservation file format that you can't go wrong with if you choose this format. That being said, although TIFF is the gold standard, as we have discussed, uncompressed file formats are quite large and can cause a huge drain on storage resources. A good alternative and an emerging master file format of choice is JPEG 2000. JPEG 2000 is a losslessly compressed file format, which is 95% smaller than its corresponding TIFF file. It is gaining adoption, and not only is being used by the Library of Congress, but as more and more organizations have an eye towards sustainability, they are looking for ways to reduce not only the cost of digitization on their budgets, but also their environment. Now, either TIFF and JPEG 2000 are appropriate file formats for still image, but if you're digitizing textual content, you could also select the PDF-A file format. This file format is meant for archival material, and it can be displayed exactly as it is going forward. So it does this by limiting the type of content that could be included in a PDF-A. It doesn't include audiovisual material or any sort of scripting or software, but it is kind of the self-contained environment, and it's a good option if you're looking to save a smaller file of textual material. So again, as we look at these various options, there is not one right answer, but rather more and less appropriate choices for your particular project at your particular institution. So whatever you choose, be thoughtful about your selection of file formats. And although you can migrate to another format if necessary, you should avoid the temptation to change formats frequently. So now that you know the different ways you can package your files, let's look at what goes into them, starting with pixels. The building block of a digital image is the pixel, which stands for picture element. A pixel is the smallest discrete unit of information in the image's structure. Think of a digital image like a grid, where each square represents a pixel and each pixel is assigned a value. It could be black or white, a shade of gray, or a color. You can see from this image of a grid of a white and black blocks. The black blocks are individual pixels, but our brain interprets this information of the pixels to represent the letter H. Now, that's a very simplified example, so let's look at something a little bit more complicated. In this example, we see an image of a panda represented by black, white, and gray pixels. We can see each pixel laid out on the grid. We can guess what it is. It looks kind of sort of like a panda, but there's no real sharpness or detail to the image. Now, this image has low resolution, and the number of pixels in an image determines its resolution. When you talk about digital objects, resolution is often described in PPI, or pixels per inch. Usually, the higher the resolution, and therefore the more pixels per inch, the higher the image quality. Now, in this next image of the panda, you can't even see the individual pixels. This image has a much higher resolution. There are more individual pixels representing the image, allowing for more sharpness and detail to be able to be resolved in the image. Now, does that mean that you should digitize to the highest possible resolution your equipment can produce? Definitely not. Remember, the higher the resolution you scan at, the longer it takes to capture that image, the larger the resulting file size, and the more resources it takes to digitally preserve that file over time. At a certain point, no matter how high the resolution is, you will not be improving the digital image quality. The goal is to find the right balance, to identify the necessary resolution to capture the informational content of the original without exceeding it. Now, image scientists have determined that for reflective material, such as photographic prints and documents, the target resolution is about 4,000 pixels along the longest edge. For transmissive materials, such as slides or negatives, the target resolution is about 6,000 pixels along the longest edge. Now, I'm really not good at doing math on the fly, so I rely on a handful of resources to help identify the target resolution when I'm scanning. Now, we've already discussed the FADGI technical guidelines for digitizing cultural heritage materials and how they have those really helpful charts for determining the target resolution for the various media types. So in addition to that, the Association for Library Collections and Technical Services published minimum digitization capture recommendations, which provides minimum resolution and color mode recommendations for digital capture. This resource is very helpful as well because it provides examples of scans at increasing resolutions of the same object so you can see the difference and compare. For example, on the image here, there are scans at 200 ppi up to 700 ppi. In the 200 ppi scan on the far left, you can see the individual pixels, and the scan doesn't capture the detail of the hash marks. Now, as you move from left to right, you can see that around 400 ppi, you can start to see the individual brush marks clearly, and you don't see the pixels anymore, the individual pixels. But then again, if you keep going all the way to the end, you'll see that after about 400 ppi, the image quality doesn't really increase in any sort of meaningful way. So this is a great illustration of that graph in the previous slide, where the increased resolution only improves image quality up until a certain point. After that, you're only increasing the size of the file and not its quality. The other resource I wanted to mention was the Sustainable Heritage Network's very helpful resolution chart for image digitization. So this is something that can easily just be printed out and hung up where your scanning station is as a quick reference. You can easily identify the appropriate resolution using this by selecting your original format by the type along the top, measuring the long edge of the material you'll be digitizing, and then using the chart to identify the corresponding resolution for that material at that length. Now, this is not going to be exact for everything you digitize. A lot will depend on the content of the original you're digitizing. If the text is very small or fine, you'll likely need a higher resolution to capture that fine detail. These guides can be considered a jumping off point, and you'll likely have to do some testing with your particular material, your particular equipment to determine the ideal resolution. Now, if you're just looking for general guides to apply to a wide range of material, scanning between 300 to 400 ppi should be sufficient for most formats besides transmissive material. For textual material, you'll likely need to digitize to a sufficient resolution to run optical character recognition software. Now, most text material is about the content and not the way it's represented, so you can scan to 300 ppi if you're scanning to grayscale. If you're scanning to bitonal, just the black and white, it's recommended that you increase the resolution to about double that, to 600 ppi. Now, even though this seems like it would be twice as large, it's really going to provide better it's going to provide a much better resolution than a grayscale at a lower resolution. All right, so for images on reflective media, not transmissive, where the light is reflected and not passed through, the goal should be around 400 ppi. So again, we're in this 300 to 400 ppi range that's going to get you good results. This is not the case for transmissive material where the light is transmitted through an object such as a photographic slide or a negative. This is going to be much higher, mostly because these originals are much smaller and meant to be enlarged when they are being presented or shown or used to actually print images. So for this, we'll be doing a lot of that magnification by digitizing them at a resolution of around 3,000 to 4,000 ppi. So there's more to scanning than just determining an item's resolution. If the resolution is the quantity or the number of pixels, everything after that can be considered the quality of those pixels. So pixels are made up of bits. A bit, or a binary digit, is the smallest unit of measurement in a binary system. Bits are represented as either a 1 or a 0. The number of bits, or the numbers of ones or zeros that define each pixel, is known as its bit depth. The higher the bit depth, the more information can be represented in that pixel. Bit depths range from 1 to 48 usually, with common bit depths of 1, 8, and 24. So let's look at some common bit depths for digital images. The first is bitonal, which is 1 bit. That pixel can be represented by one of two possible values. It's either going to be black or white, a 1 or a 0. Now, grayscale files are usually 8-bit. They can also be 16-bit. So this means that there are 2 to the 8th power, or 256 possible values that pixel can be, from 0 being black to 255 being white, like pure black and pure white. So you can see black, white, and then the whole range from black all the way to white and all the 256 possible values in between. Now, when we add in color, color files are usually 24-bit. They can also be 48-bit. But those bits are divided among the 3 color channels in an RGB color model, which we'll talk about in a second. But that's going to be red, green, and blue channels. So it's really 8 bits per color channel of the red, green, and blue. So if there's 256 possible values for each of those channels, there's over 16 million possible values for each pixel. Well, let's take a look at color a little bit closer and see how that turns into digital images. So I mentioned before about RGB, and that's something that we call a color mode. But what is a color mode? It's the way we turn colors into numbers or data, because as humans, we can perceive color. Computers cannot perceive color, but they can understand color as data. And there's a few different types of color modes, and the most common that we're familiar with most likely are RGB and CMYK. So RGB stands for red, green, and blue, and this is additive. This is an additive color mode, meaning that you start with black and you add light to create colors, and the result of all the colors together is white. Now, RGB is what's used for digital photography, computer monitors, websites, etc. Basically, anything you digitize and put into a digital space is likely going to be an RGB color mode. The other color mode that you're more than likely familiar with is CMYK, which stands for cyan, magenta, yellow, and black, with the K representing black. This is subtractive, meaning take colors away to get to white. And this is used for printing mostly. So your printer image, you have to refill your cyan, you have to refill your magenta. These are used for printers. Now, both of these, both RGB and CMYK color modes, the chroma and the color and the luma or the brightness are combined into the same channels. That means like if you adjust the red, you're also adjusting the brightness of that hue, not just the color. And this isn't always the best way to manage these elements because the human eye is really attuned to brightness, and it's more attuned to brightness or luminance than it is to color. Now, because of this, they have other modes developed where the chroma and the luma are separated out into their own channels. And so what we see in digital imaging is the LAB color model. And this is used for still images where the brightness or the luminescence is separated out from the chroma. And that's the L value, where the color values are on an axis, where A is from red to green and B is from blue to yellow. So you have a few different things going on there. So even though the LAB color model is more closely resembling human perception of color, where brightness and colors are separate, there are very few applications and file formats that support it, which is why FADGI guidelines recommend using the RGB color mode. Now, when you're digitizing visual material, you have a few options for color spaces. A color space is a specific organization of colors that supports reproducible representations of color in combinations with color profiling supported by various devices. Each color space can represent a particular gamut or range of colors. Now, in the image on the right, you'll see that it represents a few different things. First, the rounded horseshoe shape is the range of visible color, what we as humans can see. Now, inside that horseshoe are three color spaces: sRGB, Adobe RGB 1998, and ProPhoto RGB. sRGB, or standard RGB, is the smallest of the color spaces. You can see it's the smallest triangle there. Now, this is considered the lowest common denominator color space, and it's what most monitors can display. The Adobe RGB 1998 color space is a slightly smaller gamut than ProPhoto, but it still covers a significant portion of the visible color spectrum. Now, Adobe RGB is widely adopted, it's supported by many applications, and it covers most of what CMYK has available in its color space for printing. So you can go back and forth, not that you should, but you could go from RGB to CMYK. And last is ProPhoto RGB. Now, this is the largest of the color spaces in terms of the gamut of color that it covers, but you can also see, especially at the top and at the bottom left, where it extends beyond the range of visible colors. So Adobe RGB 1998 and ProPhoto RGB are recommended color spaces in FADGI guidelines, but most of what you're going to be using is Adobe RGB 1998, depending on your material, unless you're using really specialized equipment. If you're digitizing to grayscale, gray gamma 2.2 is the FADGI recommended color space for that. Now, in all of your scanning, color is preferred, but grayscale may be appropriate in many instances. So again, this is a choice. There are lots of choices to make. It is not a simple one-to-one. Okay, so we've gone over formats, resolution, bit depth, and color. And now it's time to make some choices. So I have a couple exercises that I hope you'll help participate with. And I'm going to show you some examples of material to be digitized. And we can just kind of talk about what might be appropriate for the specifications for those materials. So you can feel free to drop things in the chat or to unmute yourselves, and we can go from there. So for this exercise A, this is a postcard. It's just the standard postcard, 4.5 inches by 6 inches. It's in color. It is in good condition. So does anyone want to start by dropping into the chat or unmuting yourself and saying what file format might be appropriate for this postcard?
I can tell you what I would do.
That's exactly what I'd love to hear. What would you do?
I have about 1,000 of them right behind me. I scan all of our postcards to 600, and I use TIFF.
Tip
I
600.
have a graphic arts scanner, so I use a lot of file space, but we have our own server. So
Well, good. Then you have space for it. And what do you scan these to color? Do you scan them to grayscale? What are you scanning these to?
always color. Yeah,
Always color. Do you know what color space you're using?
I'm pretty sure it's the Pro,
The Pro Photo?
but I'll have to go back and double check my equipment. I'm not 100%. That was a new one for me. So.
Great. Thanks, Lisa. Does anybody think a different file format, or you have any reasons why you think that you might want to choose something else? Heidi's saying sRGB color, 600 ppi, uncompressed TIFF, and then a 150 ppi JPEG for access. Yeah, these are both great. These are both great. So this is what we kind of recommended. So either TIFF or JPEG 2000. So Lisa's doing TIFF, Heidi's doing TIFF. Makes sense, uncompressed TIFF. Kind of a range here depending on the detail in the postcard. So both of you are looking for 600. That looks good. I had, between 400 and 850, really kind of depending. Bit depth of 24. Color mode of color, and either the Adobe RGB or the Pro Photo. So Heidi, is there a reason that you would do sRGB over Adobe RGB, or is it just what your resources allow or what your equipment allows? It's not a wrong answer either. It's like, these are all, again, choices about our individual collections, what our resources are, Oh, right. So Heidi's saying this was the default before her time, and she might revisit that. And that's okay, because you know what? If you scan to sRGB, then pretty much any monitor in the country will be able to resolve that image. You'll be able to see that with the colors represented. Monitors are pretty good at automatically displaying what they're capable of, which is something you always have to keep in mind when you are, looking at what you're digitizing to see if your monitor is calibrated and actually showing what it's supposed to. But so the good news is, if you're scanning to sRGB, then what you're seeing and what you're scanning is what people everywhere are going to be able to see if they're interacting with it on a monitor. Well, great. Thank you. Thank you guys for participating. I've got a couple more, so let's move on to exercise B. So this is a 35 millimeter still image. It was black and white film. So feel free to, you can drop in the chat, unmute yourself. Again, what preservation file format might you choose for this? What do you think your target resolution would be? Oh yeah, at least I see about the postcards on the back, especially, pencil written on the back. It can be hard to pick up some of that content. Definitely. Anyone want to throw something out? 1200 to 2400 ppi TIFF. We have traditionally scanned black and white in color here, and then make black and white JPEG for access. Great. Yeah, and again, that's a choice. Whether you do it in color or grayscale, for black and white originals, that's a choice. Scan it at 1200 ppi for publication TIFF. Great. Yeah. So Heidi, you bring up a good point, just looking at kind of what I've put down. So an uncompressed TIFF or JPEG 2000. I have a slightly higher resolution, just around 3000 or 4000. Again, it depends on what the content is. It depends on the level of resolution that's needed. And you could do this as grayscale. So, 8-bit grayscale, or you could digitize black and white material as color and then make choices from there, because you can always go back if you scan in color and turn it into grayscale, but you can't go the other way around. I mean, you can, but it would be essentially inventing content that's not there in your original scan versus removing those chroma values and just leaving the luminescence values. We find the print is fine for research purposes, but we'll pull the negative whenever available. Yes, definitely. So this brings up a really good point about scanning from negatives versus scanning from prints. If you have a choice to ever scan a negative or the film of something versus a print, it's always recommended that you go and you scan from the negative if it's in good condition. Sometimes, they're very fragile, so the emulsion gets scratched really easily. And then in that case, the print might be in better condition. You also have to consider, depending on if it's, the negative is the starting off point. So a lot of times artists will make decisions in terms of exposure and other sort of artistic elements that they might have on the print that's not in the original. So that's also something to consider. And do you capture one or the other? Do you capture both? Do you have the space for both? That sort of thing. Yeah. Saying, seeing the colors that show up in scans. Yeah, a lot of times you'll notice that sort of sepia tone, that sort of brownish yellowish color. And there's a lot to be said for making decisions about what you're trying to capture, because when you're digitizing something, you are being an intermediary for that object. So are you going to be digitizing the object as it is now? Are you going to be digitizing that object for what it would have been like when it was originally created, what maybe that original intent was? So maybe it doesn't have that sort of color fading, or maybe you're going to be digitizing it to what the goal would be. So we're talking about, that print, the negative versus the print. So if you have the negative, but in the print that there were artistic choices made to make it different than the negative, then do you digitize to make it closer to what that print was? So there's a lot of choices to be made, and I've said it throughout this presentation, and these are sort of more about, it's mostly been about passive choices, like, okay, what's the best for this medium, what's the best for this, for our resources to be able to continue to provide access to this in the longer term. But then it also asks those other questions about what other kind of choices, like, yeah. Oh, and I see also you're at the DIA, artists having their own aesthetic or artistic choices, and how do we either communicate those in a digital way when a lot of the people who I'm sure are doing research wouldn't have access to that otherwise. So that's great. Yeah, there's a lot of decisions, and you can't think that anything that's digitized didn't have some layer of interference in some way, whether it was intentional or not, whether it was, being able to kind of document these decisions, like we talked about earlier in one of the earlier sections, okay, I'm going to document what my file choices and my file specifications are. So if you're going to be digitizing them to, for one choice over the other, make sure that you're documenting that. So you're saying, okay, well, we're doing this because this is what it looks like now, and we're going to maintain that, versus we're digitizing it for how it would have looked when it was originally made. Either choice has value. Just make sure you document it so that when people go back and they look at these, just like you would if you were processing collections, like what are these decisions, and what contextual information can you give about why they were made? This is great. Thank you. I love this, that you're all willing to share. That's great. All right, I've got two more. So this is an unbound document. It's just textual information. It doesn't contain images. What do you got? Hey, Stephanie is saying PDF grayscale. Anybody else? Well, Stephanie, I agree with you. Yep, I would digitize this to a PDFA format, around 300 PPI, do a grayscale. Again, depending on what the content is, you could do this as bitonal and then just bump up the resolution to 600 PPI. In general, I prefer grayscale instead of bitonal, but it just really depends on speed and what resources are. it's interesting. I just was working with somebody on a digitization project of some library files here, and it was bitonal, and it was great because there were some handwritten notes in some documents from the 1940s that I could not make out in the physical object, but by doing bitonal with really high contrast, I was able to see what the indentation actually was. So that was really interesting, but I would say overall grayscale is going to be more appropriate for this type of content. All right, awesome. Thank you. All right, this last one, exercise D, this is a bound diary for the 2-page spread. We're looking at about 8 inches by 12 inches. What are we thinking? What file format and resolution? Yeah, color, TIFF, 400 ppi. Okay, right there with you. Uncompressed TIFF, 300, 400 ppi, color, 24 bits. I think, if we're digitizing to these specs, we're going to get some really good representation of the original material. People are going to be able to read from it, and hopefully it'll be a really good digital resource. Well, thank you, everyone. I really appreciate your input. Just to kind of go over the key points from today. As we've seen, there is not one right answer for every original across every institution. Your scanning specifications are going to vary depending on a variety of factors. There are many resources to help guide your decisions. You are not alone. I reference things all the time because I have other things in my brain. So FADGI, the minimum requirements, these are really great resources to have at your disposal. Again, we're going to be scanning at a high enough resolution to capture the content of the original, but no more. Do not give them your extra storage. You're only going to increase the size of the file with no added image quality. And when in doubt, 300, 400 ppi should be sufficient for most formats. So we have a couple minutes left for questions. So if you have any, feel free to drop them in the chat. Unmute yourselves. I'm happy to hang out. I know we're getting close to the end. Give it a second. But while you're thinking, if you have any questions, I just want to remind you that our next class in the How to Pick series is going to be how to pick your partner. And it's going to be working with digitization vendors. We'll be looking at factors to consider when determining whether to use a vendor, how to request quotes, and how to ensure that the work you're doing was done right. So Becky will drop in a link to register if you're interested or would like to share that. That's going to be, again, August 29th. And I'm just going to leave here because there is a survey. If you want to take the survey to help us improve programming, I'd love to hear your feedback. I'd also like to thank the Institute for Museum and Library Services for making this presentation possible. Any questions, comments? Well, I will hang out for a couple minutes, but otherwise, thank you all so much for joining me. I really loved the conversation and the input. It just helps us all know that we're on the same page. We're doing this together. Thank you all.